Hello, thought I'd do a quick recording of, well, maybe not quick, we'll see how this goes, of me solving the tic-tac-toe-turn lab, part of the Introduction to Ruby track for the Learn Verified program. So let's go over the directions here, or the instructions. So a turn of tic-tac-toe is composed of the following routine. You're going to ask the user for their input, either 1 through 9. Again, tic-tac-toe board has 9 spaces, so you're going to ask the user for input 1 through 9. You're going to receive the user input. You're going to convert that position to an index, because again, the board is going to be an array, and as we know with arrays, they start at index 0. So we need to make sure that whatever they input, we convert it to that corresponding space in the array. We need to check to make sure that the move is valid. If so, we're going to make the move and display that board to the user. And if it's invalid, we're going to ask for a new move until the user enters a valid move. And even though this entire flow is going to be inside the turn method, the majority of the logic is going to be encapsulated in other methods, other individual methods that's going to work with this turn method. So this is just a quick pseudocode for turn, and then here are the different instructions for the other methods that we're going to be building so that we can complete the turn method. So I'm going to go ahead and clone down this lab here. We're going to use just the standard Atom text editor. It's going to look like the IDE. Most of you folks are going to be using the Learn IDE, but this is just Atom here. So I like to do my projects in a Learn directory here, so we're going to clone this down. And again, a lot of you folks are going to be using Learn commands to fork and clone your labs, but I'm going to be using Git commands. So it's just going to take some time to clone this down because I'm in a hotel right now and the Wi-Fi is pretty bad. So it's taking a little bit of time to clone this down. In the meantime, let's go back to the instructions here. So the first method they're having us build is a display board method. If you've gone through the Intro to Ruby track, then you've probably already built this display board method. So I figure we'll go through building that. And then you got to move on to valid move. And then they talk about the workflow using a fail fast so we can stop after each failing test. And again, we like to utilize test-driven development, so that's a great thing, especially when you're working on a lab with 50, 60 tests. Sometimes doing a fail fast works because stops after the first failed test, you get that to pass, then you move on. Cool. All right, so now that we've cloned it down, let's go ahead and cd into that directory and open it up in our text editor. Perfect. Okay, so turn lib directory turn.rb is where we'll be writing our app here. And let's go back to the instructions. So it says the first method it wants us to build is the display board method. If you're doing this Intro to Ruby track, you've probably already built that yourself in a previous lab, but it takes in a board as an argument, which is an array of either spaces and X's or O's, depending on the state of the board. And we're going to print that out to the user. So first let's run an rspec fail fast so we can fail, or it'll stop after the first failed test. And you'll see here no method error, and this is undefined method display board. So let's go ahead and define that method. And it's called display board. It's going to take in board as an argument, and if we run fail fast again, it'll still give us an error probably, but now it's going to be a different error. So it's going to expect the output to include a row with 3 X's. So again, we're going to use string interpolation, which again, if you're going through this track, you've learned about. So we're going to put, and forgot to interpolate that, and 0 is going to be the first element. 1 and 2. Forgot to close this one. There we go. And we're going to do that 3 more times. Oh, closing one there. And then in between, we're going to output the horizontal line, which I believe is 11 slashes or dashes. 11. Copy that. Paste. Let's run the test. See what we've got. Okay. Hang on. Sure, we just have an extra. Oh, that's right. We need to change our indexes. So this is 3. This is 6. This is going to be 4. This is going to be 7. And this is going to be 5. This is going to be 8. So it's our spec again. Cool. So now we passed the first test, and now we're failing the second test. So this let's go back to the instructions here. This is where I kind of veer away. Once the failure references a particular method in the instructions, that's when I'll go back to that. But not right now. I like to see what the current test that's failing is and build that particular method. So we're getting another no method error, so undefined method input to index. So let's go ahead and define that method. And let's pull up the spec. And here is that method. So it converts a user input to an integer, and the way it calls it is it takes in an argument. So expect input to index, and it passes in user input. And we're going to convert that to an actual integer, because right now it's a string that the test uses. So let's go ahead and go back to turn. So it takes in argument. I'm just going to call it input. Doesn't need to match what the test is calling it. And again, what we're going to do is we're going to take that input and we're going to convert it to an integer, and we're going to subtract 1. Because again, the test is passing in a string of 1, but we need to convert that to an integer of 0, because we're talking about arrays and array indexes, which start at 0. So that should pass. Let's go ahead and see what happens. Perfect, and that passed 3 more tests. So you can see here the display board test passes, and all 3 of our input index tests pass. Next is valid move. So let's go back to valid move. So it should accept a board and an index. So those are the 2 parameters or arguments it takes in. And return true if the index is within the correct range, 0 through 8. And is currently unoccupied by an X or O token. And here's a hint here. Again, if you've been through this track, you've already built a method called position taken. So we're gonna also build that method in this lab, so we can use it as a helper method for our valid move. So let's go ahead and define valid move. And again, board index. So again, a valid move is one where the index is within a correct range and it's currently unoccupied. So if I write it in pseudocode, is index is within a range 0 through 8, and board at index is not occupied. Okay, so that's our pseudocode for this particular method. So let's try to find some sort of method we can use to check that this index is within this particular range. So let's just go to the Google. Ruby check if an integer is in range. Let's just check this first top one here, Stack Overflow, which is going to be your good friend as a programmer. Okay, so it's like we've got a method called between. So you can use, you can call between on a particular number that you're checking to see if it's between the range that you pass in. And one way we can do is try IRB. So 14 dot between 10, 20, true. 14 dot between 10, and let's try 12. False. Cool. That seems like the method that we can use for our particular program here. So the number we're checking is index. So we're going to replace 14 with index. And the range is 0 and 8. So that should satisfy this part of the AND. And again, we want both of these conditions to be true for this to be a valid move. So we're going to use the AND operator. And here's where we'll define our position taken method that our valid move method can use. And again, that's also going to take a board and an index. And position taken, the way position taken works is it's going to return true if the board at that index is not equal to a blank space. So board index, and again, these are the two variables we're passing in, is not equal to a blank space. Because if the board at that index is not equal to a blank space, then the position is taken. Does that make sense? So that returns true in that sense, but we want it where the board at that index is not occupied. So we can use the bang operator to return the opposite value. And the way I like to phrase it is position is not taken, because we've got this in front of it. And again, that bang operator always returns the opposite value. Okay? Cool. So let's test this out here. Cool. So it looks like that worked. Now we've got our move method. So the way the move method works, it accepts a board, an index from the user, which was converted from the raw input with input to index, and a token to mark that position with. And again, the token's either going to be an X or an O. It says here we can give the argument a default value of X. So let's go ahead and just start building that method out here. So def move board index, we'll call it player, and we'll give it a default argument of X. Just to add some spacing there to make it a little cleaner. And the method should set the correct index value of that position within the board equal to the token. And I guess we can just change this to token since they keep referencing token. So we're going to take the board at that particular index and we're going to set it equal to token. we'll see how that goes. Cool. So now we have 7 examples because we passed the move method. So now we can finally build our turn method. So if we go back to the pseudocode for the turn method, first let's define it, because again we've got that no method or error. And let's go to the spec again and see how that method is being called. Cool. You just pass in, it just takes in one board, so one argument there. So let's go ahead and fail fast. We'll get to this point. So now it's expecting us to prompt the user. So I'm just going to copy this here. And we're going to put, oops. We're going to get input. We're going to call it input equals excuse me. Gets.strip. Now we're also going to convert that input to an appropriate index by calling our input to index method, and we're going to pass in the input. We'll actually update this variable name to user input. Cool, so now we've converted that to an index. So now we want to check, here we go, if index is valid. So now we're going to use our valid move method here. So if valid move, and valid move takes in a board as well as an index, and we have that here. And again, these don't need to match these variable names. I can also change this to user index if I wanted to, and it'll still work. So again, these do not need to match. So I'm just going to keep it this way to illustrate that point. So if this is a valid move, then we're going to make a move, board in user index, and we're just going to use those two because it already has a default, or we're just going to have it default to X for the token, and we're going to display the board because those are the next steps. Show the board, and we're going to use our display board method that we defined up there. So that's all if it's a valid move. If it's not a valid move, what should we do? Let's go back to the pseudocode. Ask for input again until you get a valid input. Now, we could, if we wanted to, do another puts, please enter, and do this whole thing again, but that just seems like a repeat of what we did up here. So what is a way for us to start at the top again if this move is not valid, if the user input was not valid? Well, you've probably heard of the term recursion, and just in very simple terms, it's where a method calls itself. And it does get a little more complicated, but just in very simple terms, it's where a method calls itself. So the way we can do that here is we can call the turn method and pass in the board. And what it's going to do is we're going to go back to the top, and we're going to prompt the user again for input. So that's what we should do if this move is not valid. So if the user enters a 20 here, well, valid move will return false, so it'll drop into this else condition, and then turn board is going to get called. So we're going to stop. We're going to go back to the top again, and the user is going to be prompted for a new input. So that should be the bulk of that method. So let's go ahead and run tests, and there we go, all green. So hope that made sense. So even though this was our main method that we wanted to build, we needed all these other methods as helper methods to be able to complete this entire, or this one method here. So hope that made sense. Pretty straightforward. So hope to do more of these videos, walkthroughs, and again, these walkthroughs I want you to go through once you've solved the lab, and not try to watch these before or during the lab, because I want you to get a different take on how a particular problem was solved, and then you can compare it to the way you solved it. So it's just a better way of learning, is once you've solved it on your own, and then you see how someone else solved it, it just reinforces your learning, and it allows you to solve different problems in different ways. So I think that's all I have for now. Thanks, guys.